www.libertarian-party.ru.
You see, indeed. So the first thing I want to show you, I'm going to show in this talk 2 ways of studying sun-climate connection. This is the first way. The first way is very exciting because I met these 2 guys from Ireland. They are also, by the way, PhD trained chemists. They are not that stupid. They always say we are stupid, but we are pretty smart, by the way. And so these 2 guys I met, and we hook up together. We ask some very simple questions. Hey, look at all this thermometer station, right? So this is one of the examples. Here I want you to focus on the red curve, which is the northern hemisphere average, because that's the part where we have confidence doing it for now. It has a curve that warm up to about 1930s and 40s, and then it cool a little bit until 70s, and then it warm up like that again. And I propose to you that the last part of the warming is completely not man-made. Well, it's man-made, but it's artificial. It's nothing to do with climate, okay? It's having to do with the thermometer bias, right? That you are actually, again, it's one of those urban heat island effect kind of problems, you know? And then the question then is like, why don't we study all the climate stations that are actually only use the rural station that potentially not contaminated by all these problems of development and human development, right? Even that was not done. So in that case, I'm proud to be the first one to do it, right? Too bad for them. So this is part of the problem, right? You cannot possibly use this temperature record, can you? Unless you correct for it. So it's a baloney. I mean, this temperature record really, first of all, is near the wall. There's a vent coming out. There's all kinds of problems. No. You shouldn't ever use those kind of things. To show the example, just pick this example. One is the station at Tokyo. Wow, big city. That's a mega city, really. 10, 15 million people, that's it. And then there's one island off the coast of Japan, you can imagine. It's called Hachijojima, right? If you look at the temperature record, the blue curve is actually from the island, and then the red curve is the Tokyo. And if you think that is global warming, by the way, they actually are using some of that record to make those kind of claims. They're kind of having some kind of amnesia to say that you can use Tokyo to prove that CO2 is warming Tokyo, right? It's not going to happen, believe me. It's completely related to what you do. It's your thermometer station history, that kind of problem. So we start with this record. This work was done in 2014, 2015 when I met them, and then we just say, why don't we test this idea out? Do you know that I actually do not know what the result is going to be? Science is always a process of inquiry. That is beautiful, really. And I'll show you the result. We just say, why don't we start there? Okay? We don't dare to touch Europe because we really don't have the station history. But that will be done, of course. Here's one of the sample of all the record of all the rural stations. Don't try to hurt your eye, but it's the whole idea is that from this 4 region, you can make a northern hemisphere composite. Okay? Even if you don't like it, oh, not enough data, that's fine. This is what we can do. Because you rather study something to know what is going on first. So the bottom curve is what I want to emphasize. Look what is looking like now. It's warm from about 1880 to about 1930s, 40s. It cool and then it go up again. But it has a very different look, isn't it? You guys remember how the other curve looked like from the NASA Goddard Institute of Space Study? That headed by Jim Hansen, the guy that I quote from New York Times, who testified in the US Senate, saying that in 1988 that we're already 99% confident, right? But they were looking at the floor record. And that's how the comparison is, right? They're basically looking at like a hockey stick, really. But we're actually having a curve that is actually quite similar in a scientific language. We're looking at multi-decadal changes, right? Changes of the temperature that kind of oscillatory in some sense. But which is the correct record? That's actually the question. It's a very empirical question, very simple to ask, and one should test it out, right? Okay, let me start. The first one is that if you look at the northern hemisphere sea surface, remember, those thermometer records sits on land. So why don't we study the sea surface temperature? Okay, there are 2 ways of plotting the result. You can guide your own eyes, your own eye. The sea surface temperature kind of have that imprint, isn't it? It doesn't have the one that warm and then go up, which means the modern warm period is much warmer than the 40s, right? Those are not real actually. But it looks more similar to our curve, okay? And then if you look at even a newest way of looking at it, is basically looking at ocean heat content. These are, by the way, is from a simulation data set, so it's slightly different. But it does show this warm period of the 30s and the 40s, starting the column of the ocean from about surface to about 300 meters down, right? And then if you look at another measure, which is actually the glacial length of the northern hemisphere, covering all this region, including Greenland and Europe and Asia, high mountain area. If you look at the glacial length, it does show that the 1930s and 40s warm, and then the modern warm period is not that warm, okay? Of course, glacier is measured in actually the length of the front of the glacier, right? It's a different units. Even tree rings, although it's not reliable for multi-decadal changes, because tree rings are very sensitive to very fast changes, so it can't detect what you call year-to-year sort of changes, that 10 years to 10 years, but it cannot do the every 50 years too well, but it's not too bad actually, right? So understanding the strengths and weaknesses of your data set is another very important criteria. And then after we've done this work, another beautiful thing about science is basically we were not interested in satellite data because it's too short. But people are saying, why don't you show the satellite data? Okay, all right, okay, let's take a look. If we're wrong, we're wrong. Just right here, I'm wrong, I'll go home now, sleep. But the satellite data is not too bad. It's not agreeing every single up and down on the interannual places, but the 2005 to 2008 kind of period is a bit suspicious. But I don't have time to deal with this tiny little stuff, but that's what it is. But if you look at it overlapping on our record, it's not too bad, isn't it? This is purely, blind kind of test. Nobody was manipulating anything, okay? By the way, the satellite records are reliable in that sense, okay? Because you are actually measuring the microwave emission from the oxygen molecule, and it's very uniform. So it has no problem of the kind that is sitting on the surface or even the sea surface temperature data. So it's really interesting that you got to have certain consistency in the data sets before you go any further, right? This is basically maybe not so useful, just to show you that science is all about numbers. The sun is indeed very energetic. It is actually, at least in terms of power, measured in watts. It's at least 1 billion times, right? More powerful than the Earth's heat, for example. And then even now, the world's most powerful laser, now we are very close to be able to produce that, but those are very short pulses, right? So that's really differences between giant stuff versus little laser powers, but we are getting there by studying science properly. And now I wanted to show you a video of this sunspot journey to try to open your mind in terms of what we should study about the sun.
For recovery? That's outrageous. I had a real plan. Any fool can understand. The advice real simple. Boost aggregate demand. CIG altogether gets to Y. Keep that total growing. Watch the economy fly. We've been going back and forth for a century. I want to steer markets. I want them set free. There's a boom and bust cycle and good reason to fear it. Play low interest rates. It's the animal spirit. You see, it's all about spending. Hear the register cha-ching. Circular flow. The dough is everything. So if that flow is getting low, doesn't matter the reason. We need more government spending. Now it's stimulus season, so forget about saving. Get it straight out of your head. Like I said, in the long run, we're all dead. Savings is destruction, that's the paradox of thrift. Don't keep money in your pocket or that growth will never lift. Because business is driven by the animal spirits, the bull and the bear. And there's reasons to fear its effects on capital investment, income and growth. That's why the state should fill the gap with stimulus, both the monetary and the fiscal. They're equally correct. Public works, digging ditches, war has the same effect. Even a broken window helps the glass man have some wealth. The multiplier driving higher the economy's health. And if the central bank's interest rate policy tanks a look.
All right, so the question to ask is that what is causing that temperature curve that I show you? The red curve is basically the solar irradiance estimate, right? It kind of fit according to Al Gore, you know? Because he said it was, you don't need no science. It was his classmate Baba that figured out that North Africa and South Africa and this kind of fit. That's what he said. You don't need to study science. And next thing is basically to try to explain that why I think that this irradiance curve is what is to be believed, okay? I say believe because it's still a very hard problem, because to try to understand how the sun does that, I'm very sorry, it might take a very long time really to figure that out, but now we're working on science on the empirical level, not to the level of understanding that we say we can really do something serious. And then since I come from USA, because USA indeed has the best temperature record. If you look at the best collection of World Meteorological Organization temperature record from all over the world, the United States cover about 50 to 60% of the station. This is why we actually have a new work now that have a breakthrough to quantify all this non-climatic effect. But for this study, we only take the rural station to avoid this contamination problem at 2015 when we were studying. But really, all you're looking at is some kind of correlation. What the hell make Willi Suna so smart, right? It's about collecting stamps, you know what I mean? Homer Simpson actually got a stamp of his own. I think I need an Al Gore stamp very soon. But what's the real reason actually, right? It is really like a sun stupid kind of thing, you know, but I don't want to trivialize science. The problem is that science is very serious. One should not turn everything into a cartoon. This is the problem. We are dealing with cartoon science for a very long time now. This is why it's very serious to study this carefully. Which means I know every up and down of all this temperature curve. And basically, the simplest answer is that, you know what? When you have more radiation impacting on the surface, you evaporate more. As simple as that. Roughly. That is more than enough to explain all the changes, roughly, on multi-decadal time scale. If you want to work on year-to-year changes, you have to understand how the sun can do something to ENSO or something. Maybe it has nothing to do with the sun, but for the problem of multi-decadal changes, to me, it's as simple as that. You don't need anything more complicated. You definitely do not need CO2. So, yeah, I mean, now I want to explain. Again, these people say that all my work has been debunked, but they always show only one thing and then they don't show the rest of it. This is now the full disclosure of all the estimate of the solar irradiance. The top part is basically what we call it high variability. These are basically solar irradiance estimate from about 1800 to present time, right? The high estimate is completely ignored by IPCC by now. The bottom is the one that favored by IPCC. There are about 5 or 6 of them. They all agree with each other. But they are completely not independent. They assume that the solar irradiance changes. By the way, the picture I show you is to give you the hint that it's much more complicated than just sunspot alone, okay? This whole curve that they show at the bottom is completely can be fitted by the sunspot number record. Sunspot number record is a convenient metric, but it means nothing when it comes down to the bottom part when you're near 0. Because 0 compared to 0 is the same 0. But no two sunspot minima are really the same, isn't it? That is the problem. Science is about quantification. That's the kind of problem they have.